Hi, my name is Varun Patel and I am Product Manager with Lynx Technik AG. In this video, I will give you a brief introduction to HDR, High Dynamic Range, and will explain some of the current HDR and SDR workflows in the broadcast industry. Later in the video, I will introduce you to Machine HDR Evie, which is the world's first real-time dynamic HDR to SDR converter. So let's begin. Moving to high dynamic range, or HDR, is arguably one of the most innovative advances for the viewer experience in recent years. HDR provides an image that more accurately represents the scene being captured. The emergence of high dynamic range acquisition in live and studio production has brought numerous possibilities for improved picture quality and creating an immersive experience for the viewers. It's worth reminding ourselves of the problem HDR solves. It provides an image that more accurately represents the scene being captured. There are different types of transfer characteristics that are supported by the cameras these days. PQ-ST2084, HLG, and Sony S-Log3 are some of the prominent HDR standards. The two major color spaces in HDR standards are BT 2020 and BT 709. But before we delve deeper into HDR, let's first understand what HDR means. HDR stands for High Dynamic Range, which most of us thought was just more brightness on our television. But this is not 100% correct. HDR means a lot more than just brightness. A dynamic range of a scene is the ratio of maximum light intensity to the minimum light intensity. High dynamic range image increases the possibility to have a higher scene contrast range during recording, processing, distribution, and playback on displays. HDR solves one problem, and that is to provide an image that more accurately represents the scene being captured. This results in greater details in highlights, greater details in shadows, better tonal range, and more vibrant colors than the traditional standard dynamic range video. HDR is the technology that expands the brightness peak from 100 nits to a range of 1000 to 10,000 nits. Standard dynamic range is currently the most widely used standard for video and cinema displays. Unlike HDR, standard dynamic range is limited to represent only a fraction of dynamic range that HDR is capable of. Restricted to a maximum brightness peak of 100 nits to 500 nits, the range offered by a standard dynamic range format is way less than high dynamic range standard. But if all sounds nice about high dynamic range standards as compared to standard dynamic range, then why do we need an SDR video at all? The reason is that not everyone has a high dynamic range display. It is estimated that over 80% of the population around the globe are still watching their favorite sport on a standard dynamic range screen. Moreover, even today, most of the installed so-called HDR displays are not even capable of handling more than 300 nits. Therefore, it becomes pertinent to have an SDR feed along with the high dynamic range for distribution. But identifying what workflow to include in the production is a major challenge for some of the broadcasters. Currently, there are three prominent workflows that are being used in the broadcasting industry. The first approach is a parallel HDR and SDR workflow in which the camera is optimized to standard dynamic range, producing a good standard dynamic range video, but results in a compromised high dynamic range video. The second approach is a parallel HDR and SDR workflow in which the camera is optimized to high dynamic range, producing a good HDR video, but requires a lot of effort to get a good SDR video through SDR shading via gain adjustment. The third approach is to have a camera optimized to HDR and down convert the signal from HDR to SDR via static conversion. This approach works well for studio environment where the lighting conditions do not change dynamically, but it is not suitable for outside live broadcasts. All these approaches require a lot of resources and are expensive to manage. Implementing correct workflows is not the only challenge that broadcasters face. In the outside broadcasting, many times broadcasters have to deal with the blown out highlights and lack of shadow details on the SDR image. And to overcome this problem, broadcasters have to invest heavily on their time and money on setting up fill lights or floodlights that helps overcome the blown up highlights and lack of shadow details issues. Apart from the loss of time and money for broadcasters, the use of floodlights makes the talent or presenter uncomfortable due to the heat generated and light falling directly on their face, and therefore they require frequent adjustment on their makeup. Introducing Green Machine HDR Evie, the world's first and the only dynamic HDR to SDR converter solution. Green Machine HDR Evie from Lynx Technik AG was developed in close collaboration with University of Applied Sciences in Wiesbaden, Germany. Single HDR workflow is inherently the best approach in HDR and SDR production as it requires less resources, incurs less cost, and saves a lot of time. And as compared to static down conversion, having a dynamic HDR to SDR conversion eliminates the struggle of adjusting iris and gain simultaneously in a dynamically changing light conditions. But what is dynamic HDR to SDR conversion? And how is HDR Evie different from other converters? Let's take a look at two types of high dynamic range to standard dynamic range converters that are currently being used in the live broadcast environment. The first type is static HDR to SDR converter, and the second type is dynamic HDR to SDR converter. The traditional approach is called static down conversion, in which a knee function is used to incorporate luminance information which would normally be outside the SDR range. The static down conversion applies color and contrast parameters equally throughout a specific piece of content. The capabilities of such systems are very limited, and at high contrast range at some point leads to a flat looking image. Static HDR down conversion is most suitable and reliable solution for studio environment where the lighting conditions do not change dynamically. The second approach and the recommended approach for live HDR down conversion is called dynamic HDR down conversion. Dynamic HDR down conversion enables live automatic contrast compression, avoiding artifacts inherent in classic tone mapping technique. HDR Evie algorithm automatically detects and brightens the dark areas of the videos while at the same time retrieves the details in overexposed sections. As a result, viewer can see what is happening in all parts of the image. HDR Evie performs that by capturing one frame at a time, analyzing it, and applying correction parameters to it. Changes in luma also affects the color impression, and that is why in the last two steps, chroma is automatically adjusted to luma. All these steps are performed in real time. The overall latency of the system is just one frame delay. Let's have a look at how static and dynamic converters are different. Static converters apply contrast parameters equally throughout the piece of content, while dynamic converters apply contrast parameters frame by frame in real time. To explain that, let's take a look at an HDR image histogram. If a static converter is used for the down conversion, then all the luminance information that lies within the static window will be captured onto the SDR image. Any information that lies outside the static window will be clipped off. For a static converter, it does not matter how the scene looks like. It keeps applying the same contrast parameter to the image. The static window is always fixed and does not change its position or size when the scene changes. In case of dynamic conversion, the dynamic window does not have a fixed width like static window. The algorithm analyzes the frame and determines the most suitable width for the dynamic window to incorporate maximum possible information of an HDR onto the SDR image. It therefore reduces the clipping and captures more information of HDR as compared to static conversion. In dynamic window, the algorithm also identifies the best position of the dynamic window which would incorporate the best possible HDR impression on an HDR image. After adjusting the location, the algorithm adjusts the width of the dynamic window to create the image which is most preferred by the viewers. This dynamic window will remain same if the scene does not change much in the lighting condition. But when the algorithm senses a considerable difference in the lighting condition, then it will automatically find the best dynamic window to create the best possible HDR image without needing a manual adjustment. Powered by award-winning platform Green Machine, HDR Evie is a complete package for live broadcast HDR and SDR need. It supports all the major input transfer characteristics and converts them to standard dynamic range. The Green Machine HDR Evie hardware supports two operation modes: 3G quad channel configuration or 4K UHD single channel configuration. In half 19-inch rack size, Green Machine is one of the most powerful hardware present in the market. Green Machine HDR Evie will not only simplify your workflow, reduce cost of equipment, but also it will help you save your time. Green Machine HDR Evie can be configured using the front panel keypad or using the graphical user interface designed to be used on the PC. If you are looking forward to more information on Green Machine HDR Evie, then log on to www.lynx-technik.com. To find the nearest dealer, click on where to buy on the website and request for a demo.